In this first video, we're going to look at what a derivative is. So if you look here, I've plotted 3 straight line graphs, and the equations are y equals 2x, y equals 3x, and y equals negative 2x. And they're all straight lines. Y equals 3x is going to be steeper than y equals 2x, because the gradient of a straight line is the number in front of the x value. So here we've got y equals 2x, 3x, and negative 2x. The negative is the one that's sloping down. But all these 3 lines, they have a gradient, which is a certain number, and that's the same everywhere along the line. So if I get rid of 2 of these and only keep y equals 2x, I can see it more clearly. So this line has the same gradient everywhere along the line. But how about if I change my equation to y equals x squared? Let's see what that looks like. So y equals x squared, we get something like this. It's a curve rather than a straight line. And that means that at each point here, we're going to have a different gradient, because it's steeper in the beginning, and then it's less steep near the middle here. So if I change the windows, we can see it a bit better. So we'll change the y min just to -1. So now we should be able to see it a bit better. And let's change the x window as well slightly. Okay, so now we can see the line. And we can imagine drawing lines that go along this line at different points, and they would all have different gradients depending on where they are. So you're going to learn later on how to calculate the tangent, but I'm going to draw one for now. So y equals 2x minus 1 should give us a line which just touches our curve here. And at this point, the gradient of the curve happens to be 2, because the line that we plotted that was a tangent was y equals 2x minus 1. So because it's 2x, it means that the gradient is 2, which means that the gradient of the curve at this point here, where they meet, is also 2. So the gradient of a curve changes all along. And what the gradient is at each point, that's what's called a derivative.